Yes, guys, welcome to our today's session. We are going to move forward. Remember, guys, this is our last recording concerning spanning tree protocol, right? So today we are going to talk about some of the features of spanning tree protocol, right? So I will try to share my screen, right? Yeah, so we are going to talk about some of the features of spanning tree protocol, right? So what you have to understand is this. Number one, by default, spanning tree protocol will be running on your device, right? So you're gonna have your switches, right? By default, spanning tree will be running. There is no need for you to start activating it. So spanning tree protocol will be running already, right? And number two, you have to understand that spanning tree will start sending messages to neighbors' computers, right? Sorry, guys. So when you have two switches, one switch here and another switch, right? Those two switches will try to talk, will start exchanging messages. Those messages, we call them what? BPDU, right? So BPDU, they're just like messages that will be sent between switches. So in order to exchange spanning tree protocol messages or informations, right? So let me show you how it can happen, right? Suppose like I have my switch here, switch number one. So, and there's another switch here, right? So switch number one will send some BPDU to switch number two. So, and switch number two can do the same, right? Those messages, we call those type of messages BPDU, right? Because when, like I have my switch, right? How my switch will know about other switches when it comes to spanning tree protocol, right? My switch will know about your switch because we are connected. So I will learn about your spanning tree protocol informations by sending some BPDU, by sending some messages, right, to you, and you too, you can respond in order for us to understand what's going on, right? So number one, your spanning tree protocol will be running by default. Number two, how spanning tree will know about other switches by sending messages that we call BPDU, right? And number three, right? Number three, spanning tree will have like a default priority of 32,768. So this is a default priority, but you can change this priority, right? So for every switch, by default, the priority will be 32,768. And number four, every segment required a designated port. So when you connect two switches and you have a segment, that link, that cable, that link, one of the port will be a designated port, right? So for every link, there must be a designated port, right? Number five, so if you add like a new switch with lower priority or lower bridge ID to your topology, so it will be elected as the root bridge. So what does this mean? You have your topology, you have already your switches, right? There is already like a root bridge, right? Suppose like switch number one, this is your root bridge, right? When you add a new switch, if that switch comes with a lower priority, right, means that switch will be chosen or elected as a root bridge, right? So you have your switches, you got already your root bridge, but if there is another switch that will come with a lower priority, that switch will be chosen or elected as a root bridge. Number 7, for number 6, you can change the priority number, but it must be a multiple of. So you can change the priority numbers of a particular switch, all right? But if you change it, so it must be a priority of this number. No. So it must be a multiple of this number. So for you to find the multiple of this number, you have to multiply this same number by every integer that you know, right? Times 2, like here. So you're gonna have an answer. This one again by 3, right? You find an answer. So those answers here, those are the multiples of this number. So for you to get like a multiple of a particular number, you have to multiply that number by every integers. Like maybe, so I'm asking you, what is the multiple of 5? So you're gonna say 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20, right? So 1 or 5, 10, 15, and 20, those are the multiples of a number 5, right? So when you change your priority, you must take like a multiple of this particular number, right? Now, for you to change the priority, so this is the command, right? First, let me go to packet tracer. You can go to your packet tracer. I can try to drag and drop like maybe those 3 switches. This one we can connect it on first 10 at 0/1. I can take this one, the 10 one. I can take the 11 one. And here I can take the 15, 16, 2. So and you're gonna have maybe one PC there and like another PC here. You can connect wherever you like, but you must follow some, right? Okay. So if you wanna change the priority number, this is the command, spanning tree VLAN 10. This VLAN 10, you can put your own number, right? You can say VLAN number here, spot priority, right? So you have to precise according to the way you created those VLAN, right? Let me show you first how you can learn about your spanning tree, right? Okay, so I'm gonna go to switch number 1. You go to CLI, right? Suppose like guys, so I wanna learn something about my spanning tree protocol, right? So I wanna know about my priority, right? So, and other related informations, such as my root bridge, my designated port, right? My routing port. You can just say show spanning tree, right? Show spanning tree. By typing show spanning tree, so I can learn something. So I can learn about my switch, like in terms of spanning tree configurations, right? You can see here, most of the time, the root ID, but you must look at your bridge ID with extended one. You can see, right? You must look at the bridge ID. So this is the MAC address of what? Of that switch. You can see that I'm using my interfaces. Those are the interfaces that I'm using, there are only 3 because I plugged my switch to 2 switches, right? And there is 1 port for the computer, means I'm using 3. The role, you can see that FA0/2 is a designated port. Designated port means that port can forward a data. You can see here, you can see the costs. My cost, it's what? 19. This one is a root bridge, no, root port. You can see it says root, forwardings, and the cost, right? But you can also go further, right? By saying just show spanning tree, right? Show spanning tree is question mark. By pressing the question mark, you can see all the options that comes with spanning tree. So you can use show spanning tree, it's active, show spanning tree detail, right? So those are the options that we can use after show space spanning tree, right? So I can use the summary, right? So you can get more information there, right? By using the summary. Okay, let's go back to my document, right? Now you have to understand that these guys, when you have those 3, or maybe those 3 switches, right? There is the switch 1, switch 2, and switch 3, right? You connect them, right, by using the first Ethernet port, and from here you use the gigabit port, right? Gigabit and gigabit, right? For every link there is a cost. Like link from switch number 1 to switch number 2, there is a cost. That cost maybe can be the speed required between those 2 switches, or maybe it can be the bandwidth that required for those 2 links to be connected, right? Maybe it can be the delay, how many seconds so it's gonna take for your packet or your frame to go from switch 1 to switch number 2, right? So this is what we call like a cost. So it's gonna cost you what for you to come from S1 to S2. But if you are using fast Ethernet, your cost will be what? 19. This is the cost by default, right? But if you go for gigabit, the cost is number 4 by default, right? And here also is number 4, right? So this is what does it means. So when you are using the gigabit, the Ethernet, the cost is always 4. The fast Ethernet, the cost is always 19. So when you link 2 switches, there is a cost. But that cost will depend if you are using the fast Ethernet or gigabit. Fast Ethernet, the cost will be 19. Gigabit, it's gonna be 4. Okay, let me go to my packet tracer. So I can add another switch here. So, and that switch, I will connect it using the gigabit, right? You're gonna see here, I'm gonna use the gigabit one. So in order for you to understand what I'm talking about, right? So as I said, for every link, there is a cost, right? You're gonna see that the cost here is gonna be 19. Why? Because with fast Ethernet, 19. This one is gonna be 19, but this one is gonna be 4. Why 4? Because we are using the gigabit Ethernet, right? Because we are using the gigabit Ethernet. So I'm waiting it to be like orange, right? So I can also do this. I can try to connect also like this, just right. Right, so I'm just waiting it to be green. So in order for me to check what I want to explain like to you, right? So, and remember here it's fast Ethernet, it's gonna be 19, right? Gonna be 19. Right? So what you're gonna do now, we're gonna go to this switch, right? So I wanna learn something about my topology when it comes to spanning tree protocol. So I'm gonna say show spanning tree. You press enter, right? You can see that this switch, right, uses 4 cables by using those 4 interfaces. You can see them here. But when you look at the gigabit, the one that we added, you can see that the role is designated, means that port can send. This one, so that it's green. Status, yeah, forwarding means that port can send. But the cost is what? The cost is 4. Why? Because it's a gigabit length, right? This is the meaning, right? This is how you can check. And remember, guys, wherever you see the orange means those are the blocking port. So when you see like a port showing like orange, means it's a blocking port. So, and remember, guys, I told you from here that you can change your spanning tree, your port priority, or you can change the priorities of your switch, right, by typing this command, right? So like maybe you are here, right? You want to change the priorities of this switch. You're going to just go, right? You're going to change like the priority, right? You can say maybe spanning tree, spanning. So I'm pressing tab, right? Now, suppose like you forgot, but you want to change the priority. Suppose like you forgot, you can say question mark, right? Those are the options. Let's say VLAN, right? So I can say maybe VLAN 9, question mark. So what is the priority? Right? Priority can say 4096, right? So this is how you can change the priority for a specific VLAN, right? We can go back to my document. Yeah. You can also change like the costs. This cost, you can change it. The costs, right? So, and the command, it's easy, right? So as I said, when you are here, you can just say span, you press tab. So it's gonna come like spanning tree, right? Now you said, okay, what do I want? So I wanna change like the cost, but you forgot about the comment. The only thing that can remind you is that spanning tree. You're gonna say it's question mark. From the question mark, you can say, okay, let me take the VLAN. It's question mark, right? Okay, you can say, okay, they say that they can pick up a number. So VLAN 2 maybe. It's question mark, right? But you see here, so it doesn't give you that option, but you can go maybe for root. No options, right? So we have to exit from here, or maybe I can keep it like primary, right? Why it doesn't give us the option? Because when we are talking about a cost, we're talking about a link. That link, we want to change the cost of the link, not for the entire switch, but the cost of a particular link, right? Because that cost is for a specific link. It's not for the whole switch. So you cannot be in global configuration mode. You must be like under a particular interface. So I can say maybe interface first Ethernet 0/3, right? So now for me, I can say span So you can press tab, question mark, right? So you can see here it says already like cost, right? You can go for VLAN first, or you can go to cost straight. But if you have VLAN, you can go for VLAN. You're gonna type cost. Now they're gonna ask you what is the number. You can say my number is like 30. This question mark, there is nothing, you can press enter. Right? So with spanning tree, most of the time I'm gonna say just spanning tree question mark, right? Okay, let's move forward. You can also disable spanning tree, right? For a particular interface. So you don't want spanning tree to run like in one of the interface. You're gonna be like for this one, we're gonna say no spanning tree VLAN. Right? Now there is a way you can force like a particular switch to become a root bridge, right? You can force like a particular port to become a root bridge by saying what? Spanning tree VLAN 10 root primary. Primary means you are forcing that switch to be a root bridge. You as an administrator, you can decide to do so. So when you say root primary means you are forcing that switch to be, but remember, like here, you're gonna pick up your own number according to the VLAN that you created, right? And when you say that your root primary, like switch number 1 is your root, the primary, the priority will be reduced to 24. It's 24,576, right? Now, we're gonna see what we call STP port state, right? When you have a switch, when you plug your cable, right, that port will use spanning tree protocol, right? But that port, because it's using spanning tree protocol, that port will evaluate, will move, will use what we call 4 states, right? So for every port, when you plug your cable, that port will move by using 4 states, right? That's why sometimes when you plug your port, it's showing green. No, when you plug, it's showing what? It's orange. So after a few minutes, so it's gonna move to what? To orange, right? So it's gonna move to orange. So from orange to green, right? So what you have to understand from here is this. When you plug like your port, you have your cable, you plug it maybe to fast Ethernet 0/1, that port will use 4 states, right? For it to come from orange to green. The first one is a blocking state. So when you plug your cable, so it's gonna show the orange. The orange means that spanning tree is blocking that port. So, and it's gonna take 20 seconds. So that port will remain blocked for 20 seconds, right? So when your port showing that orange, right, means what? That port cannot send BPDU, so cannot send frames or messages, the easiest way. So that port cannot learn about the MAC addresses, right? So I have a switch with another switch. So if I plug my cable, there is that orange, means I cannot learn MAC addresses of other switches or other computers that are connected to me. But it's gonna take me 20 seconds being blocked, right? I cannot even forward. The only thing that I can do is I can only listen. So when your port like is like in blocking state, means what? That port can only do one thing: listen to the switch is connected to it, right? Not doing something else, just listening. After 20 seconds, that port will move to what we call listening mode, right? On this particular mode, so it's gonna take 15 minutes, right? So your port will move from blocking to listening. From the listening mode, the switch cannot forward frames. The switch cannot learn MAC addresses of that particular switch and other devices connected to that switch. But the switch can do what? The switch can listen and send the BPDU, the messages related to spanning tree protocol. Whatever that talks about spanning tree protocol, that's from this particular state, your switch, your port can send and receive spanning tree messages. So after listening, your port will move to the learning part, learning mode. From the learning mode, so it's gonna take also what? 15 seconds. From the learning mode, the switch will learn MAC addresses of the switch that is connected to it, right? So if you're connected to me, from state number 3, learning mode, I will learn about your MAC address, and the MAC addresses for other devices may be connected to you, right? But you cannot forward. You can only learn MAC addresses from the learning part. Remember, guys, they're going to ask you so many questions. From which state a switch can only listen? You know that it's from the blocking state. From which state a switch can only listen and sending BPDU, the frames related to spanning tree protocol, listening mode. From which state a switch can learn about MAC addresses in the learning mode. After the learning mode, your switch will move now to forwarding, the forwarding mode. From forwarding mode, your switch can learn about MAC addresses, your switch can listen, your switch can send BPDU, and your switch can forward data. That way, you can see the green color, or the green LID means that port is ready now to learn about MAC addresses, to listen and sending spanning tree protocol like information, what we call BPDU, and that switch can also forward data, right? So when you see that orange, when you plug, you have to think about spanning tree protocol port state. You must think about those 4 states. You must know that, no, why still like in orange? Because that port still in blocking state. So, and from blocking state, there is nothing that this port can do beside listening to spanning tree protocol information. So after that, my port will move to the listening state or mode. From the listening state, my port can send and receive information related to spanning tree protocol, but still not sending or forwarding messages. From number 3, my port will move to forwarding. No, will move to learning. From the learning part, this is where my switch will build a database, because my switch will learn about the physical addresses or MAC addresses connected to it, but still cannot forward. So after that, my switch will do what? Will move to the forwarding mode. This is where now my port will change to green. My port is ready to send, to receive, and to learn about MAC addresses, right? So this is how, guys, you have to understand about this spanning tree protocol. When you are writing the exam, sometimes they just giving to you like a screenshot, but from the screenshot, you will know which switch is a root bridge, right? Like here, when you go here, when you go, maybe you can go to every switch, right? When you say show spanning tree, right? You see, like this switch will have a root port, right? When there's a root port, means this is not a root bridge. So a root bridge doesn't have a root port. A root bridge will have only a designated port. But we can learn about the role of every port. But you can see like this one is blocked, right? This like FA0/16 is blocked. And when you go here, you're gonna see it. So the color is what? It's orange. Why is it blocked? It's blocked by spanning tree a protocol to avoid the loop. When you go to this switch, right? So, and you wanna say show spanning tree, right? You can see that this port doesn't have a root port. Means this is your root bridge because there is no a root port, right? But if you come here and you do the same thing, show spanning tree, right? You can see there's a root port, right? This is how you can identify like a root port and so on, right? So this is what you have to go, and guys, you have to practice, do the same things as myself, right? So thank you very much. We are going to meet for the next recording.